Hey everyone, this is Nick from First Coast Math Clinic. In this video, we're going to do a proof of the Pythagorean Theorem. Let's get into it. So the Pythagorean Theorem proof we're going to do is one by the Indian mathematician Bhaskara. Now, Bhaskara was an Indian mathematician, astronomer, and engineer who was born in the year 1114 AD, and he made notable contributions to the field of algebra, trigonometry, calculus, and astronomy. He was one of the first mathematicians to use the decimal point number system as well as the decimal point. Additionally, his text was the first to identify positive and negative solutions to square roots of positive numbers. However, another notable contribution was his proof of the Pythagorean theorem, known as Bhaskara's proof. This proof combines a little bit of algebra and geometry, and we're going to use this figure right here to do our proof. We have a square with 4 right triangles, and then a square inside. I posted a link to this handout in the description if you want to follow along. All right, let's get into it. So we know our Pythagorean theorem is c squared equals a squared plus b squared. And we want to use this shape to prove this. So here's how we're going to do this. We've got 4 right triangles and a square here. So I'm going to start by just making right angles in each of these right triangles. And I'm going to label our sides in these right triangles A, B, and C. Now the hypotenuse, so the side across from the right angle, that's going to be, we have this right angle here, that's going to be our side C. And I'm going to label this inside the triangles. So let me clean this up and we'll do that. So I'm going to label these sides C, 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 and C. All right, now of our 2 remaining sides, we have the shorter side here, and we have the longer side here. That shorter side, I'm going to name A. So this is going to be A, and A, and the longer side is going to be B. All right, let's think about what we have here. So we've got our figure, our right triangles labeled A, B, and C. We want to find the area of this larger shape here, this total figure. If I want to find the area, well, how would I do that? I know that we've got C here, and this length here is length C. So to find our area, well, we could just multiply those 2 sides, C times C, and our area is equal to C squared. So the area of this whole shape here, everything that's here, is going to be C squared. So that gives us the C squared part of our Pythagorean theorem. We just need to get A squared and B squared now. So we've labeled the right triangles. Let's label this square inside here. Well, let's look at what we know. We know this length here is B. And we know this length here is A. So if I want an expression to represent this length, what can I do with B and A? Well, I can subtract them. I know B is larger than A, so I want the difference. I want B minus A. And that's going to give me this length here in blue. That's going to be the same for each of these sides, B minus A. All right, so we have everything labeled as we need. Let's break this figure apart now. So what we're going to do, if you're following along, we're going to cut this shape out along the lines, along the black lines. So we're going to have 4 right triangles and this white square. We're going to rearrange this and try to get our area, the area of the figure in terms of A. All right, so we have our figure labeled as we did on the previous slide, and I cut out the pieces here. So I want to rearrange this to see if we can get our area in terms of A and B. Now we notice that our original shape, we've got C on the outside, so C, 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 and C. And if you're following along, you could cut this out as well. Now I can grab this and move these pieces around. So I'm going to show you how I'm going to move these pieces. So I'm going to take this first piece, I'm going to drag it, rotate it, I'm going to put it right here. And I'm going to do the same thing with, let's take this piece. I'm going to rotate it. I'll line it up like this. So now we have a rectangle. We have A on the top and bottom, and B on the sides. Move this out of the way. I'm going to do the same thing with these two triangles here. So I'm going to rotate this. I'm going to take this. So we're going to take this piece here, rotate it, and we can make another rectangle here. Notice we've got A and B on the outside, and then we've got our square here with sides B minus A. So we can put that right here. All right, so now we've got two rectangles with sides A and B on the outside, and a square with side B minus A on the outside. So now we can find the area of the shape in terms of A and B. Okay, so we have our rearranged figure here. And we have on the outside, we've got A, B, A, B, A, B, and then B minus A, B minus A on the outside of our figure. So now we can find the area of our figure, our shape, in terms of A and B. So just a review, previous slide, we had C on the outside, C and C. So we found the area of this shape in terms of C, and we figured out the area of this figure is C squared. We have 4 right triangles and 1 square. We didn't take away any triangles, we didn't take away the square, we just rearranged them. So the area has to be the same, and we want to get this Pythagorean theorem back. C squared equals A squared plus B squared. Well, we know that since we didn't remove any figures here, whatever the area of this shape is, it has to be equal to C squared. All right, because we just moved around all these pieces. We didn't take any of them away. So now let's find the area of this shape using A, B, and B minus A. This rectangle here in green. Well, how do I find the area of that rectangle? Well, my dimensions are A and B, so that's going to be A times B. So A times B, that's the area of the rectangle in green. Then how do I find the area of this rectangle here in red? My dimensions again are A and B. So I'm going to add in another A times B, and that's the area of the rectangle in red. Now I want to find the area of this square here in blue. Well, what are my dimensions? My dimensions are B minus A, B minus A. So I could do plus B minus A times B minus A, or B minus A squared. So let's simplify this. AB plus AB is going to give us 2AB plus, now I want to square this binomial here, B minus A squared. I have a video on squaring a binomial. The link will come up at the end of this video if you want to review, but we're going to square the first term. So it's going to be B squared. We're going to square the last term plus A squared. And we want to multiply A times B times 2. So it's going to be minus 2AB. So that's our rule to square a binomial. Remember, if we have just a quick review, if I have x minus y squared, our rule is we want to square the first term. We want to square the last term. We want to keep that sign for the middle term. Multiply the two terms, and then multiply them by 2. So this is our rule for squaring a binomial. All right, we just use that here to get our b squared minus 2ab plus a squared. So now let's simplify everything that's here. So let's look at what terms we can combine, right? Well, we've got 2ab minus 2ab bring that plus a squared here, plus b squared. So you guys see what's going to happen here. 2ab minus 2ab. Well, that's just going to cancel out. That's going to be 0. And we're left with c squared equals a squared plus b squared, which, as we know, is our Pythagorean theorem. All right, so just as a review, we took one original shape, this shape, found the area of it in terms of c, and got c squared, which gave us this. Then we just took all those parts, cut them out, and found the area in terms of a and b, which gave us a squared plus b squared. And since we didn't remove any pieces, we didn't add any pieces, we know the areas have to be equal to each other. And we got our formula c squared equals a squared plus b squared, which is Pythagorean theorem. So this video was on Bhaskara's proof of the Pythagorean theorem. I hope you guys like this video. If you like this video, remember to like, comment, and subscribe. You can check out the link for the video that's coming up right now, which is a review on squaring binomials, as well as another video on Pythagorean's theorem. This is Nick from First Coast Math Clinic.